Hi, this is Leetcode question word break. We will use dynamic programming to solve this question, and we will use we will solve it in two different ways. The first way is we create a table of length equal to the size of the string, and each index or each value of the table tb of I is either true or false. If it's true, that means the substring from 0 up to index I, this substring can be segmented into a space separated sequence. If it's false, that means this substring cannot be segmented. For example, tb of this is, or let's rewrite this string leet code, and we have these indexes 0 1 2 3 4 5 6 7, and now let's take this I equal 3. Now tb of 3 will be true because the substring from 0 to 3, the substring equal this part leet. The answer for this is true because we can segment this substring into words that exist in the dictionary, so we can just take this word. And so the answer for index 3 is true, while if we take tb of 2, this should be false because the substring from 0 to 2, which is the word li, cannot be segmented into words that exist in the dictionary, so the answer should be false. Now we need to find the answer for every index in the array, and at the end we return the answer for tb of 7 or tb dot back, and this answer tell us if the substring from 0 up to 7, which is the whole string, can be segmented into a space separated sequence. Now the question is, at every index, how can we find the solution? Let's rewrite it again. Now let's say we want to solve for I equal 7. What we will do is check every substring end at I equal 7. So we check for this substring, then for this, 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 and so on. And for every substring of these, we need to check two conditions. The first one is the substring before, so let's call this start as j, and we have I here. So this segment, let's call it substring. The first condition is the index before j minus 1, before j, which is j minus 1, up to 0. So this segment should have answer true in the table. So the segment tb of j minus 1 should be true. Or of course, if j minus 1 is less than 0, for example, if we start with j equals 0, in this case j minus 1 is less than 0. In this case also it's a valid case. So this is the first condition, either TP of j minus 1 equal true or j equal 0. The second condition is this substring here should exist in the word dictionary. So substring should exist in this word dictionary. If these two conditions apply, that means TB of I is true. Now let's see how this work. Let's start with I equal 0. Again, let's rewrite the string Leetcode, and initially TB has 0 values, have 0, 1. These are the indexes, 3, 4, 5, 6. We have 1, 2, 3, 4, 5, 6, 7, 8 characters, and the values, as we said, are false. 0 means false. Now we need to find a solution for I equal 0. We iterate over all elements from 0 up to I, because we need to check for all the substring that end at I equals 0. And so the only possibility here is j equal 0. Now this first condition apply, j equals 0. Now we need to check if substring from j to I, which is the word L, if this word exists in the dictionary. In this case it's not, so this condition does not apply. And then j equal 1, this 1 greater than I, here we check for j until j equal I. So we are done with I equal 0, and the result is false. Next, I equal 1. Now again, let's start with j equal 0. From j equal 0 to I equal 1, the substring is, so first of all this condition apply, j equal 0, then the substring is LE. Now LE does not exist in the dictionary. Next, so it's false. Next we check for j equal 1. So this is j equal 1. Now from j equal 1 to I equal 1, the word is, or the substring is E, and E does not exist in the dictionary. So again, this condition does not apply. That means for I equal 1 also the answer is false. And then we move to I equal 2, and we start with j equal 0. From 0 to 2, so j equal 0, this condition apply. Substring is from 0 to 2 is Li, and this cannot, or this word does not exist in the dictionary. So j equal 0, this condition does not apply. We move to j equal 1. From 1 to 2, substring is E, and this word does not exist. Then we move to j equal 2. From 2 to 2, the word is, or the substring is E, and this substring, or this word does not exist in the dictionary. And that means for I equal 2 also the answer is false, and that's true because the substring from 0 to 2, which is Li, this word cannot be segmented into a space separated word that exists in the dictionary. Next we check for I equal 3, and we start with j equal 0. J equal 0, this condition apply. Now from 0 to 3, what is the word? It's leet. And because j equals 0, this condition apply. Is leet exist in the dictionary? Yes. So the two conditions apply. This condition apply. Notice here we having this set. It's just reformat or refilling this vector into an order set in order to find if the string exists in big O of 1 operation. And so the two conditions apply. In this case, we set tb of I to true. So tb of 3 equal true. Next, tb or I equal 4. We start with j equals 0. From 0 to 4, the word is or the substring is leet C. Now, is this exist in the dictionary? No. So for j equals 0, the answer is false. Then we move for j equal 1. Now, remember, we forget to talk about this condition. So when j equal 1, first of all, we check if tb of j minus 1, which is tb of 0, if it's true, tb of 0 is false, so no need even to check for the substring if it exists in the dictionary. This apply also for the previous check we did previously. So j equal 1 does not apply. The answer is false. J equal 2 also, we check tb of 2 minus 1, which is 1. tb of 1 is false, so no need to continue. J equal 3. tb of 2 is also false, no need to continue. Now j equal 4. tb of 3 is 1, so it's good. So this condition apply. Now we need to check the substring from j equal 4 to I equal 4, which is the letter C itself. Now, does this substring exist in the dictionary? No. That means one of the condition or this condition does not apply, and we are done with I equal 4, so the answer will stay false. And we continue until 7, and 7 will be for 7 it will be true, because here I equal 7, because when j equal 4, tb of 3 is true, and the substring from j to I is code, this word, which exists in the dictionary. And so the two conditions apply, and tb of 7 will be 1, and so the final result will be 1. Now, what's the time complexity for this algorithm? First of all, changing this word dictionary vector into a set. This will iterate over all the value in the dictionary. Assume the length of the dictionary is m, and the word size is k, so m multiplied by k to copy this into this dictionary. And assume the length of the string s is n. So here we have n, and here we have another n, and the substring also is n. So we have n square multiply by or plus Okay. Now for space complexity, we reserve this set to store the value, and also we have this tb size is n, so it's big O of n plus okay. Now this is the first method. In the second method also we will use db, so we create a table db of the same size of the string, and we will solve it in different way. So let's say we want to solve for I equal 7. What we will do is iterate over the words in the dictionary. So starting from leet, we check if this word can be the word from I equal 7 up to the length of the word. So here we have 4 characters. We check if these 4 characters equal the word leet. So this is the first condition, if the substring or if the substring equal the current word. 2, if tb or db of the index next to or previous to this, so here we have 4 character, assume this is j, db of j minus 1 if it's true, db of j minus 1 should be true. If we find one word in the dictionary that meets these two conditions, then that means db of I equal true. For example, for I equal 7, this word code, because we are iterating over the word dictionary, we find this word code equal this substring, and because we solve from left to right, db of this index will be true, so the two conditions will apply, and db of 7 will be true. Another example, if we want to solve for this index, we check if this word, if there is any word in the dictionary that equal to this word, and also db of j minus 1, in this case j equals 0, in this case j equals 0, so we don't need to check the table value, so either j equals 0 or db of j minus 1 is true. And if we find one of word of the dictionary equal to the current, in this case Leetcode equal or leet equal leet, in this case db of 3 will be true. Let's take another example. Assume we are solving for I equal 4. Now let's iterate over all the words. So first loop to solve for all the indexes, and now we are at I equal 4. Now we need to check for all words. The first word is leet. Leet is 4 characters. It's 1, 2, 3, 4 up to here. What is this substring? It's E T C. Now is this word equal leet? No. So we move to the next character, the next word. The next word is code, which does not equal to this substring also. So we did not find any word that equal to the substring to this word. Also, even before checking if the word equal, also we have to check db of j minus 1. So The first word is leet, but which has 4 character, and db of 0 because j equal 1 will be false, and so this condition even will not apply. Now for the second one also the same, 4 characters. So this is the whole idea, and the time complexity for this is better than the previous one, because here we iterate n multiplied by the length or the number of words in the dictionary, which is m, and here we do substring, and substring cost n, and remember each word length is k, so the time complexity for this is n square multiplied by m k. For space complexity we reserve only this table, so the space complexity is n.